Hi, my name is XinyuGong. Today I will present our machine learning project on cirrhosis disease stage classification, which aims to classify the progress of cirrhosis in patients using clinical and demographic data. And this project is based on Mayo Clinic trial dataset containing the 418 patient records with key medical indicators, the lab results, and the treatment details. Our goal is to develop classification models to characterize the patient into the different stage of cirrhosis, providing the valuable insights for medical professional. And this presentation, we will cover the dataset and the pre-processing, the EDA, explanatory data analysis, and the model selection performance. So uh, here is our dataset, data dictionary. We contains 20 medical features to help to determine the severity of cirrhosis, including the bilirubin levels, the planet currents, the albumin levels, the prosorbion time, the drug treatment history, and so on. Our target variable is to find the disease stage. The original data set is classified the cirrhosis into multiple stage for better model performance. We combined the classification into strata stage by system, allowing the model to have the better differentiate progress level. And here. Now is our progressing step. Before training our model, we carefully prepare the data to ensure accuracy and reliability. First, for the missing value, we handle missing value by filling the numerical features with the mean and categorize the feature with the mode to contain the consistency. And encoding the target, we convert the disease stage into binary classification. Patient stage 4 were labeled as the positive, which is a 1, and the other will be labeled as 0, which is a negative. And since some numerical feature like the beryllium levels are highly skewed, we applied the log transformation to normalize their distribution. And for outliers, we use the here we use the Wissing organization, which adjusts the extreme value instead of moving them into preserved data integrately. And here, the dummy encoding for category variable like sex, drug, and endema, we use one hot encoding to convert them into numeral values. The data set was imbalanced. So here, with the fewer cirrhosis positive case, we applied this mode. And finally, we create the heat map to identify and remove the highly relative correlate feature, ensuring the model focus on the most relevant information. As for classifier, to ensure the robust model performance, we test the multiple machine learning classifier using 5-fold star-fied crossing validation. The dataset was split into training and the test set, which is 80% training and 20% set. With the z-score normalization applied to standardize the numerical variable. And we used decision tree classifier used as a baseline, but showed high variance and overfitting, performed well on training data, but poorly on the test set. Then we used the Paycre low mode classifier. This automated model selection and the hyperparameter turning were used to compare the multiple models based on the accuracy, the record, and precision and F1 scores, the extra trees classify emerged as the best model achieved. So we can got here. You can see here the highest record is 60% record. Yeah, the highest record is 60% and accuracy it's 75.77%, make it the most effective for cirrhosis prediction. So now, as we know, we think the best model to predict this is the extra tree classifier, is the ETC, because they have the balance bias, the variance reducing the overfitting, and they have the high recall, making it suitable for medical prediction, and the feature importance rank, helping the doctor understand the key risk factor. Now I will introduce some applications in the healthcare for this prediction. So this prediction can help the doctor early disease detection to help the doctor identify the high risk patients sooner, and it will assist in patient specific treatment recommendation, and it also will provide us insights to most important medical factors. So in summary, by handling the pre-processing, improve model performance by handling the missing values and standardize the data. And the extra tree classifier was the best model, which offered the high accuracy and the medical insight. And the results aligned with the real world medical knowledge, making the model with the useful for healthcare. That's all. Thank you for listening.